Hello, hello. Welcome back to school. I hope you had a wonderful ski week. In my case, it was beach week. San Diego was awesome. Today, you have a substitute teacher, so we're going to have a in-class flip lesson where I'm going to talk through the lesson. You'll take notes like normal if you were in class, and you'll work on some problems. When you're done, you'll have some independent practice problems, and then I'll have another assignment where I just want you to kind of just briefly answer some questions, and all of this will be inside Google Classroom. So when you're done with the video, when you're done with this, and you're done with your independent practice, that's when you can go into Google Classroom and access this. Fourth period, also, please go ahead and access the Google form that will be inside Classroom. That's for period 4 only. Today, our objective is students will be able to determine the rate of change from a table of values over a given interval. You'll determine the rate of change from a table of values over a given interval. Please go ahead and make sure that you write down this objective. So for prior knowledge, please make sure you go ahead and write this in your prior knowledge. We want to write this compound inequality in interval notation, and remember here in a compound inequality we have inequalities, right? Here's the term inequality, right? This is less than or equal to, and it's saying x is living between 5 and 8. It could be 5, it could be equal to 8, and we want to write that in interval notation. Remember, interval notation just has parentheses for when it is strictly less than or greater than, and it has brackets for when it's less than or equal to, or greater than or equal to. So for an interval notation for this compound inequality, it would be bracket, because I have a greater, a less than or equal to, and I put 5, comma 8, and then on this side, we kind of move this over here, it's less than or equal to, so we're going to use a bracket. Okay. I would like you guys to go ahead, write these down. Please pause the video, write down these two compound inequalities, and do that now. So these two in interval notation would be negative 82, comma 89, and I have brackets on the end. Same thing here, 27, comma 36, and since I have an equal to sign on the bottom of that inequality and an equal to sign here, it's just saying x lives between 27 and 36, and it could be those values. Okay, so for today's concept, we're going to go ahead and compare linear functions, which we spent a lot of time talking about the first semester. So remember all the way back, back to 8th grade, Ms. Agassi, Ms. McCloskey, right? All of these things were talked about there. So a linear function is when we have a straight line, right? And remember, y equals mx plus b. So please fill this in, the red line. These are linear functions, right? They have the form y equals mx plus b. A linear function has one independent variable, right? It's one that you can control, that you plug in, and it has a dependent variable, one that is affected, right? That's put on the outside. So please make sure you get these down. And then I want to tie this back into sequences. We just talked about sequences not too long ago. Sequences that are arithmetic, where we add or subtract by a constant value, those are linear functions. So a linear function, right, is a function that has the form y equals mx plus b. Also notice it has a constant rate of change, that the rate of change is constant. Exponential functions. Please go ahead and fill this in your notes. An exponential function is a function that has a variable as an exponent, hence the term exponents, right? And they generally have the form, we looked at some other ones, f of x equals a, right, which is my coefficient, times b to the x. B is my base, and then we're also missing a value 2 here. We can have vertical shift up and down by adding a k value. So f of x equals a times b to the x plus k. Geometric sequences. So when I multiply or I divide by a specific value, geometric sequences, those are exponential functions. And I hope you know when I multiply, right, that's going to give me exponential growth, and when I divide, that's going to give me exponential decay. So an exponential function, that's a function where it has an exponent in the, the variable is the exponent. So now I want to go ahead and I kind of just want to compare a linear function here, which we have, and then an exponential function here. And what I hope you notice is that the rate of change here is constant, right? It's going up at a gradual pace that is not changing. All right. So my rise over my run, right? Remember slope, rise over run. And over here, notice my rise and my run are not equal. If I was to rise 2 units here and run 2 units here, and then rise 2 units and run 2 units, notice that that's not constant, that it's not equal, right? So please make sure you go ahead, fill in your information here for these two notes. So I would like you to kind of think about, again, what's kind of the moral of the story here. What's the difference between a linear function and what's the difference between an exponential function? And again, remember that it's the rate of change, that the linear function here has an equal rate of change, right? A linear function, equal rate of change, and an exponential function, that doesn't go there, exponential function does not have an equal rate of change. And the reason for this, right, is that the slope is constant, because slope is constant in a linear function. All right, so onto our skill. We're going to go ahead and calculate an average rate of change. This is our objective for the day. We want to calculate slope from an interval, and we're going to do this with tables. So the first step is to determine the interval. Remember that we kind of talked about interval notation in our prior knowledge. And then the next 2 steps really is we're going to determine x1, y1, and we're going to determine x2, y2. Now all these are, and I want you to kind of think about like a stoplight. I'll fill in actually this last one. So I want you to think about like a stoplight, right? Like we got green, and then in the middle, right, we have yellow. That's yellow, right? And then at the top, it's red. Or is it the other way around? I don't know. Anyway, looks like that, right? I have a stoplight, okay? And we're going to get rid of yellow because yellow/purple is not important in this situation, right? So x1, y1, that's just your starting point. And I'd like you to include this here. Just put start, right? And I wish this is in green. I need to change this. And then over here, x2, y2, this is the, not in green, dude. Here we go, end. This is the end. So this is where you're going to end. We'll talk through this in a second. Lastly, we're going to go ahead and calculate the rate of change. So I'll show you how to do this in a second. Make sure you get these in your notes. These are our 4 steps. Very, very easy. Determine your interval, right? Your x1, y1, that's your start. x2, y2, that's your end. And then we're going to plug in into these formulas. So here's our average rate of change formula. It is said as delta y over delta x equals y2 minus y1 over x2 minus x1. Now don't be scared of this formula. This formula is very, very simple. You're used to it, right? All it is rise over run. Rise over run. And include this too in that formula box that you have. It says formula in your notes, and then this guy. That's all it is rise over run. Now I hope you notice, right? Remember that if I had a coordinate grid like this, what axis is this? What axis? This is my, I want to go black. Here we go. This is my y-axis, right? Okay, that controls up and down. That controls if I rise, right, or go down. Hence, right, rise. Now notice I have y values. Those are my y values, right? y2 is located here, and y1, right, is located here. All you're doing is you're just measuring the difference. What is my rise? And then my x-axis, right? That's my run. If I was to run, right, along a straight line, that's my run on the x-axis. So notice again I have my x2 and my y2. Okay. All right, so let's go through some examples. For example 1, please fill this in. It's to the right of the steps. And what we want to do is we want to determine the rate of change from 0, 3, and determine the rate of change from 9, 12. And we want to see, is this a linear function or an exponential function? So make sure you fill in these values in your table. And the first observed interval, which you're going to write, your observed interval is 0, 3. So step 1, our observed interval is 0, 3. Now what we're going to do is I want you to put x1, actually, let me go back. I want to do it over here underneath this. So put x1, and then this is x2. This is saying, hey, we're starting here. This is my starting point. And then this is my stopping point. Okay, so I'm looking, what's the slope at this value? So step 1, observed interval. Step 2, which I'm going to put in green. Step 2, what's my starting interval? Okay, and those points are 0, 16. That's my starting interval. So my ending interval is 3, 21. That's my point where I'm going to stop. So that's step 3. That's my x2, y2, and it helps if you include x1, y1, x2, y2. So make sure you include those in your notes. Okay, so now that I have my observed intervals, we're going to go ahead and calculate the rate of change. And we'll do this over here. I'll do this in yellow. So here's step 4. I'm going to plug in my rise, right, delta y, over my run, my delta x. Okay, so I plug in y2 minus y1. That is my rise. So my rise, notice here's y2, 21, minus y1, 16. Now 21 minus 16, what's 21 minus 16? Brandon, what's 21 minus 16? 5. He's doing well. It's 7 o'clock in the morning. He's got math on lock. Okay, so 5, that's my rise, over my run. Now my run is x2, right? My x2 value minus my x1 value. So x2 is 3 and x1 is 0. Now I'm going to leave Brandon alone because he's working on something else. But 3 minus 0 is 3. So my rate of change for that first interval is 5/3. That's my slope. So now I'm going to do the same exact thing for the second interval. My second observed interval, step 1, they want to know from 9 to 12. What's the slope from 9 to 12? So step 1, observed interval, 9 to 12. Step 2, determine what's my starting point. Well, here, my first value, right, is 9. So that's this location. That's my starting point, right? And then my second value is 12. That's x2. That's my second interval. So what's the slope they're asking here from 9 to 12, the rate of change? Okay, so x1, y1 is just that first point. So 9, 31, that's x1, y1, and number 3, what's my end point? That is 12, 36. 12, 36. That's my second point. Another thing I'd like to point out, x2, y2, make sure you get those. Another thing I'd like to point out, notice these are coordinate points, right? Remember x, y. X, y. These are coordinate points. These are not interval notation. So notice this is different from the brackets, right? These are just points. This is interval notation. So x1, y1, I have x2, y2. I'm going to get rid of that guy. And now we're just going to go ahead and calculate the slope here. I'm going to calculate this slope. So that is, I'm freezing here for a second. My rise, right, over my run. This is step 4, my rate of change. So my rise, right, my difference in my y's, and I'm going to go quick because I'm running out of time here. So 36 minus 31, and my run, x2 minus x1, 12 minus 9. So 36 minus 31 is 5, and 12 minus 9, that is 3. So 5/3. I have 5/3 here. This video is going to go ahead and end now.